butanol. This is the IUPAC name. Okay. So carbonyl, we can use the term, but carbonyl, if you are talking about carbonyl, then you are not talking about the functional group. Since it is the aldehyde group is there, we have to call it as beta hydroxybutanol. And we are, oh, okay, students are not there. Yeah, okay. Fast, come fast. Due to the network, this one got suddenly disconnected. Come fast. Yeah, fast. Still, students have to come. Fast. Yeah, it got disconnected, Archit. I don't know. Suddenly it got disconnected. Fine. Okay, I was telling that beta hydroxycarbonyl and all, if you tell, when you are telling carbonyl, you are not specifying the functional group. Okay? So when we have to specify the functional group, so therefore we have to call it as either beta hydroxybutyraldehyde or butanol, or we can call it as beta hydroxy 3-hydroxybutanol. Okay? So fine, Archit. So better to specify the functional group by specifying the AL. Okay? So that's where we have the intermediate product. Why I am telling this one? Because when you heat it, there will be dehydration. Otherwise, this is quite stable. Don't worry. Don't think that aldol is a highly unstable product. No, it is quite stable. But when you heat it, there will be formation of a product, that is by the dehydration. So what do you mean by dehydration? So dehydration means removal of water. So dehydration means removal of water. Once again, it is due to acidic character of the alpha hydrogen. This dehydration will undergo easily for dehydration because of acidic character of the hydrogen only. Now what will happen? Same molecule I will write here. CHOH, and this carbon I will write like this. Okay? Now still, since there is a presence of carbonyl group, so this hydrogen will be considered as alpha hydrogen. It will be considered as alpha hydrogen. Okay. So that's where we have the Archit has written E1CB mechanism, sir. So electrophilic. What is that, Archit? You have written. You are talking about this one. So due to the presence of carbonyl group, this hydrogen is considered as alpha hydrogen. Still it is having acidic character. So therefore when you heat it, there will be liberation of H plus and this will be released as OH minus. It will be released as OH minus. What I mean to tell you is there will be formation of water. So there will be formation of water, and that's where CH. Now double bond will be formed, CH, COH. So unsaturation will be there due to the liberation of water. Yeah, that's what dehydration will happen. That is majorly because of the carbonyl group where H plus acidic character, which will act as a electrophile. Yes, which will act as a electrophile. Okay, and due to that H plus, OH minus will be promoted to release. Okay, so that's where we have the unsaturation. That's where we have the unsaturation. Okay, now what will be the name of this particular molecule? Anyone? So aldol is quite stable, but when you heat it, then the reaction will be further extended, that is dehydration, where H plus acidic character is going to promote the release of OH minus by the neighboring carbon. Okay, so this side, on the other side, unsaturation cannot happen. It should be to that carbon which is next to the carbonyl group. Okay, so but2enol. Okay, but2enol. Very good. So that's where we have the product. Since there is an unsaturation, now we can call it as but2enol. No need to mention it as butane. We can write it as but2enol due to the unsaturation. Got my point? So in that case, when acetaldehyde going for condensation, alpha beta unsaturated aldehyde. Okay, so better to use the term iupacine. Better to call it as iupacine. Okay, and if you mention alpha beta chip, then this will be unsaturation. Here also unsaturation will be there. That's what understanding will be there. It is only alpha unsaturation, no beta. If you are telling beta, then once again here double bond should be there. So only at alpha carbon, where the first carbon which is involved in unsaturation, we should consider. Okay, so no need to mention beta, but still we have to use the term but2enol. But2enol. Okay, all of you have understood? If you tell alpha and beta unsaturation, then it looks like here also this carbon is also having the double bond. So whenever we are mentioning the double bond, only the first carbon we should consider which is involved in the unsaturation. Okay, so that's where but2enol will be the final product. So what is that important thing you should mention? Important thing you should mention is dilute alkaline condition. That's very important, not concentrated. It is dilute alkaline condition. It can be dilute sodium hydroxide or barium hydroxide. Okay, so anything can be used. We will go with dilute sodium hydroxide. Now that's where these two molecules, they will condense with each other to form the aldol as the intermediate, because we are further heating the solution, and due to that this aldol will not be the end product, it will be the unsaturated aldehyde will be the end product. All of you got my point? So in the examination you can expect, write the iupacine name of aldol which will be formed during the condensation of, they will give the molecule. Then you should tell which type of aldol will be formed. Okay, especially they will talk about iupacine name of those molecules will be given in the options. Or they can give the last one, that is after heating, after dehydration. Okay, all of you have understood? So that's where we have the reaction. However, what is the major cause for aldol condensations to happen? Major cause for aldol condensation to happen here is, that is because of the acidic character of the alpha hydrogen. So what I mean to tell you is, this alpha hydrogen can be easily released as H plus. Only thing is we have to provide the condition. We have to provide the condition. That is one reaction. Okay. So next one. So we will go with another aldehyde only. CH3, CH2, CHO. You should write the reaction. CH2, CHO. Which is that molecule I have taken? So that is propanol. propanol or propanaldehyde. Better word is propanol with IPSC. Propanol. Whether it's coming then? Okay. Because Purnima, she is writing something, but it's not coming. Okay. Propanol. All of you are writing? I will write. Just observe that whether whatever I have written is correct. So CH3, CH2. Now this carbon is the one which is going to have the alcohol group. So CHOH. One aldehyde carbon will be formed as alcohol. Okay. Now this carbon is the one which is going to attach to this particular carbon, not this one. Okay. So therefore we have the CH3. This will become a branch. Okay. Then CHO. All of you will agree with me? This is what it will happen. Aldol is 3-hydroxy-2-methyl pentanol. Very good. Okay. So that's where 1, 2, 3, 4, 5. Right? So I can mention it as 2, 3. So therefore as she has written, it can be 3-hydroxy-2-methyl pentanol is the aldol, which is formed by the aldol condensation of the propanol. Got my point? So 3-hydroxy-2-methyl pentanol. Okay. Now, what will happen if I heat this particular solution? Naturally, there will be liberation of water. There will be liberation of water. So, what will be the product? What will be the product? Anyone of you have written? Just send me the IPSC name. IPSC name of the product. So that is 2-methyl pent-2-enol. Okay. So CH3, CH2, CH, double bond C, CH3, CHO. Okay. This will be the product. Please remember, this hydrogen is the one which will be knocked out along with this OH minus. On the other side, double bond will not be formed. Always it is on this side only, which is near to the aldehyde carbon or carbonyl carbon. Okay? Because this carbon now still it is acting as an alpha hydrogen. This hydrogen is acting as an alpha hydrogen. But this hydrogen is not an alpha hydrogen. Okay? So that's where double bond always it will be formed this side, not on the other side. So what I mean to tell you is this side double bond will not be formed. So as she has written, I think Sanjana, as Sanjana she has written 2-methyl pent-2-enol. Okay, so that's where 2-methyl pent-2-enol. Very good. So that's where we have the molecule. 1, 2, 3, like that if you go. So 2-methyl pent-2-enol. Absolutely correct.
So will this aldol not go for another condensation?
Which one?
This particular, it
Okay.
has an alpha.
So one thing I will make it clear. If it is repeatedly going for this one, then it will become polymerization. Here polymerization is not going to happen. Okay? So 2 carbonyl group containing molecule, they will condense. Okay? And since we are heating it, they will get converted into 2-methyl pent-2-enol. Okay? This cannot go for further reaction because there is no alpha hydrogen and there is an unsaturation. Fine? So that's why we have the reaction with propanol. So what will be the end product with propanol? It will be 2-methyl pent-2-enol. That's why we are heating it to get the very stable product. Fine? Now we will go with the ketones. First we will go with the simple one. What is this? This is nothing but acetone. Which can be called as propanone. Okay, IUPAC name is propanone. Same way, another acetone. Now, when it comes to acetone, it is a symmetric ketone. Okay. Now, anyway, both the carbon will act as a alpha carbon. So that's where alpha hydrogen options are more when it comes to ketones. Now, if you provide a mild basic condition like barium hydroxide if you use, which is much weaker than that of the sodium hydroxide. If you use barium hydroxide, now easily the reaction will happen. When it comes to aldehydes, only one alpha hydrogen was the option, but here we have the two options. Right? So this is also, like that here also. So what I meant to tell you is both the carbon will not release the hydrogen. Anyone, but options are there, more options are there. So that's where ketones, we have the special feature of the ketones. So in the presence of barium hydroxide, now it will undergo for the reaction. Can any one of you guess? Now same thing, we have the carbonyl group. Okay, now we have the hydrogen. So this hydrogen will come to this oxygen and this carbon will go to this carbon. Now due to that what will happen? So there will be CH3, OH. So this one has got the hydrogen OH. Now this particular carbon, it will act as a branch now. This particular carbon, why can't barium hydroxide be used for aldehyde condensation? We can use, but when I am using barium hydroxide, efficiency will be bit less compared to sodium hydroxide with respect to aldehydes. Sanjana, barium hydroxide can be used, but since it is a very mild alkaline agent compared to sodium hydroxide, and when it comes to aldehydes, only one alpha hydrogen is the option compared to the ketones. So therefore ketones easily can go with barium hydroxide compared to aldehyde. Okay? Whether I have reached you, Sanjana? Okay. Archit has written 4-hydroxy-4-methyl-pentanone. Okay. Now this carbon will act as a branch, CH3. Okay? Because this carbon is directly attached to neighboring carbon. So CH2, because this hydrogen has been attached here. Now next one will be same, CO, CH3, CO, CH3. That's what I have written. Okay. Now 4-methyl hydroxy, 4-methyl pentanone. Very good. So we have to number it 1, 2, 3, 4, 5. So that naturally it is a pentanone. So as you people have written 4 hydroxy, 4 methyl pentanone. Pentanone. Okay. So that's where we have the molecule. No need to mention pentan 2-ol. No need to mention pentan 2-ol. It's understood that carbonyl group is present at second carbon because we have mentioned the numbering over here. Or if you want to specify, you can. Pentan 2-ol. You can specify. So 4-hydroxy 4-methyl pentan 2-ol or 4-hydroxy 4-methyl pentanone. This will be the ketol. This can be considered as ketol. Okay? Because here we have the hydroxyl group OL, then we have the ketone group. So therefore ketol as the intermediate. But overall reaction they will consider it under aldol condensation only. Okay? So that's where we have the ketol. Now when you heat it, same as that of the aldol, even ketol will undergo for dehydration. Even ketols will undergo for dehydration. Okay? Because carbonyl group is there, alpha hydrogen is there. Now the point here is unsaturation will not happen here. You can think that, sir, this is next to this carbon only. So H plus can be released from here. No. This will be released as H plus because OH and H plus they are neighbors. And this is alpha hydrogen. So therefore, always unsaturation will be present here. Okay? So that's where CH3, COH, CH3, okay? Okay, OH will be released as OH minus double bond CH, CO, CH3. This will be the product. What will be the name of this product? What will be the name of this product? Anyone? Okay. Okay. 4-methyl pent 3-enone. Okay. So when I am talking about this one, 1, 2, 3, 4, 5. Okay, it's a pentene, no doubt. Now we can write it as 4-methyl pent 3-enone. Okay, pent 3-enone. Or if I want to specify, you can specify that 4-methyl 3-ene pent 2-ol. That is also fine. Okay, so 4-methyl 3-ene pent 2-ol. That is also fine. Okay, so that's where we have the molecule. That's where we have the molecule. Okay, all of you got my point. This will be the final product when it comes to acetone. When it comes to acetone. Fine. Any doubts in this? So once again I will tell, it can be barium hydroxide or dilute NaOH. It can be used. But we are using dilute barium hydroxide because it's a mild alkali compared to sodium hydroxide. And ketones, since they have more options where more alpha hydrogens are there, it can be barium hydroxide which can replace the sodium hydroxide. But when it comes to aldehydes, it will be sodium hydroxide, which is a bit strong alkali. But we are using dilute condition, that is very important. We are not going with concentrated, we are going with dilute. Why concentrated I am telling, will come to the next part. But now it's clear? Okay. Now if I take CH3, CH2, CO, CH3. This is the reactant which will go for aldol condensation. What is the name of this molecule? 1, 2, 3, 4. That is butanone or butan-2-one. Anything is fine. So butanone, or to be more this one, butan-2-one, but not required. Simply you can write it as butanone. Okay na? So when it will go for aldol condensation, when it will go for aldol condensation, because last we have taken symmetric ketone. Now I am going with asymmetric ketone. It is not there in your this one, but still. So what will happen? Which one will be preferred? This as alpha hydrogen or this one as alpha hydrogen? Okay, Krishna is telling methyl group. All of you will agree with that? Because if this one is acting as alpha hydrogen, we are going to get the different product. If this one is acting as alpha hydrogen, we are going to get the different product. So Archit is also telling methyl carbon. That hydrogen will act as a alpha hydrogen. All of you will agree? Okay. So what will happen here is, whenever there is a liberation of alpha hydrogen, I will get two conditions. Okay. Once alpha hydrogen is liberated, once alpha hydrogen is liberated, we are going to get the two conditions. And another one is right, when alpha hydrogen is liberated, that is because H plus it is getting liberated, right? Yeah. Okay, so that's where we have the carbon ion. Already he gave the answer. Now we can see here there is an alkyl group. There is an alkyl group. Here there is no option. There is no option. Okay. So due to that, this will be bit unstable compared to this one. This will be bit unstable compared to this one. So therefore, this will be acting as a major product. Okay, this will be acting as a major product in the sense, this will be the one which will be involved as a alpha hydrogen, and the reaction will go on compared to this one. That's where stability of the carbon ion. That's where the stability of the carbon ion. Okay, so very good, Archit. So due to that, as you people have told, right side one, that is methyl carbon, will be those hydrogen which is attached to that carbon will act as a H plus or alpha hydrogen. But don't think that this is not alpha hydrogen. It is. But it is more easy for this one to release the H plus, because whatever intermediate will be formed, it will be stable. Got my point? So that's where, based on the carbon ion stability also, the reaction is going to be decided. Fine? Can you write this one? Reaction. Or you can take it as a homework. Tomorrow you should tell me the product which will be formed due to this reaction. Fine? Okay? So that is butanone. Consider methyl carbon as the one of the reactor where alpha hydrogen will be released from the methyl carbon. You can try that one. You should tell me the product. Even you can try with ethyl carbon also. Okay, ethyl carbon also. Let me see what will be the product. Okay, so both the things you can try, but if I go with stability of the carbon ion, it is methyl carbon which will be donating the H plus. Okay, na? Major product will be that one only. So tomorrow you can tell me the IUPAC name of those product. Fine. So I will stop here. So tomorrow we are going to continue, and tomorrow we are going with cross aldol condensation also. These are very important for your competitive exams also. Fine. Okay then. Thank you. Thank you very much.